Alright guys, to kick off this tutorial, I'm going to start very simple. I'm going to explain what a hash code is, the equals method, and how to use those whenever you're programming. So sometimes maybe if you're planning on making a game engine, you want your entities to have a certain special unique code for their specific instances or differences. So like, I don't know how to really explain this, but what separates an entity object from another entity object uniquely, that's how I use hash code and equals. So if you want to know the difference, like say if I have an animal object and I have one cat and then another cat, and I want to say is cat 1 equal to cat 2, you would be able to figure out the difference between these two cats based on their variables within their class. So let's get started. So I'm in my little test area here, and I'll be doing the examples in the update method here, but we're gonna ignore that for now. We're gonna make a new class. Alright, so we're gonna call this class, I guess we can go with, alright, we'll just say entity. Alright, and here, in every object is an extension of has a super object within it object. So every class you make is based off of the object class, and that means you can override specific little things in the object class, like equals, public boolean equals, and you're completely fine to override this. There's like you're supposed to in some cases. Don't get scared by what people tell you on stack trace exception or whatever, that website. Alright, override int hash code. Okay, so we have an entity. Now, what we have to do here is be sure to figure out the difference between our entities and see if they're to see if they're unique or not. And how are we gonna do that? Well, we're gonna have a public int x, public int y. You need a colon here. Sorry about that. And then public int ID. Of course, we'd have an image here to show the object, but we're not going to do that. And then public int size. And we could also use floats, but I'm not going to use floats right now. Alright, so for the hash code, how are we going to do this? Well, a hash code is a unique ID for our entity, which would mean if we had two exact same entities, their hash code should match. So if the x, y size and ID of this entity are the same, we should have matching entities. So let's also have public string name. Alright, then public entity as the constructor. And here we'll have int x, int y, int size, int ID, string name, and then this dot x equals x, this dot y equals y, this dot size equals size. Nope. This dot ID equals ID, and then this dot name equals name. Alright, so we get that part of the way. How do we make a hash code out of that? Well, we can piggyback off of how strings do it. Strings have hash codes, and I'll show this. I'll demonstrate this. String s equals string. Cool. System.out.println s. Alright, let's see what it does. It tells us string, alright, then we're going to have s.hashcode, which would be an integer. Let's press play. Alright, so that's -8919859003. Let's try it again. Let's play this again. Alright, the same number. Cool. So now we know that this is always the same no matter what. It uses an algorithm, probably based on the bytes of each letter, and then adds some appends them to this number. So like starting from 0, it would say alright, negative, and then subtracts and subtracts or something. I don't know how it works, but yeah. So let's do string t equals tring. Why not? Sorry, this is kind of funny. Alright, let's see what the hash code is. And that's different. Although it'll always remain the same for tring, it's a different hash code, but it's the same one for its own set of letters. Alright, so we know string and tring are different hash codes. Cool. Now let's try t dot equals s. Alright, it should say false. The reason why it says false is because it knows that these are both strings. If they're not both strings, it's already not going to equal the other object if they're not the same object. Now, if they are both strings, do their hash codes match? That's all we need to know, is if the hash codes match. If they do not match, they are not true. So let's try s plus t. See what happens. Alright, so that did not work. Oh, my bad. Letter s plus t. Okay. Alright, so these do match because adding s to tring equals string, which means that the hash code is the same. So let's print out the hash code. Dot hash code plus little colon in the middle, and then s dot hash code. Alright, print. Okay, so I think I messed up. There we go. So the IDs, or the hash codes, do match because s plus tring equals string. These are both the same, which holds true. These are equal only if the hash codes match. If they do not match, they are not equal objects. They are not the same instance of each other. Kind of. They don't have to be the same instance. They can be separate instances of a specific object, but their hash codes have to mean something for you to want to use it this way. Now, let's do our entity hash code. And how we're going to do this is we're going to have string hold equals, and it's going to not hold anything. And then a hold equals x plus colon plus y plus colon plus size plus another colon plus ID plus another colon plus name. Alright. So the reason I'm putting the colons in there is because it does not matter if it is a number or anything. This will make it all one line. X, Y, size, ID, and name will all be separated by a colon. Colons can be in strings, which means I can turn this into a hash code and it will be unique to all the variables in this class. So return hold.hashcode. If any of those variables change in the field, then the hold variable will change to adapt to whatever it is whenever I call this method. And that's fine. All we need to know is, at the current state, is it equal or not to another object in the same scenario? Do I want to know if this entity at 2x and 3y with the size of 10 with the ID of 0 matches at a different position with the same ID and size and name? Cool. If they don't match, they're not the same instance or the same entity in the same place. Now, the reason why I have an ID is because all of these will have unique IDs, and I can differentiate if they are the same or not. If I can differentiate, I can store them a certain way in HashMaps, because HashMaps work off of hash codes. And I'll do an example on that in a second. Now, the reason I'm explaining hash codes in the equals method. First, let me finish the equals method. Alright, so if object dot or instance of this Alright, so if object is not instance of entity, we're going to return false because we already know it's not this. We're not comparing entities. Alright, if object equals null, return false. Let's put this one first. If we're comparing a null object, or if we're comparing to null, we should already know these things aren't the same. Okay. And then if object.hashcode equals this.hashcode, return true, return false. The last one. Okay, cool. Now let's try it out. In our update method, we're going to have entity A equals new entity. We're going to have 0x0y, the size of 10, an ID of 1, and a name A. Alright. And then entity B. We're going to have it on 1, 1 with the same size, same ID, different name. Okay. System.out.println A dot equals B. And it'll tell us true or false if it equals each other. And they're not going to. Why is that? Because their hash codes are not the same. So let's see what their hash codes are. A dot hashcode, and then B dot hashcode. Alright. Well, their hash codes are pretty different. Why is that? Well, because the string we make in these are different. Alright, so that's very close. I wonder why. Well, it's probably because of the way they're arranged and the fact that it's only off by one number. And that's because A is probably an increment above B. So let's try what C does. Oh wow, well we figured something out. We figured out that the hash code is a sequence of numbers, and changing the letters changes the increment that they're differentiated by. That's pretty neat. And that's basically how it works. Now if we make the names equal, the numbers become equal. So 0, 0, 10, 1A. Cool. Now let's try changing this. Alright, well that's kind of different. In fact, this 2 is in the 4th digit space away from the decimal, and it's pretty different. And that's just how this works. Like, any instance of these being in different orders and different values will be unique, and that's all we need. And they will be unique because they're being cast into strings, or well, they're being applied into a string or setting into a string. I don't know how to best explain that, but anyway, then we get the string's hash code, which means any sequence of characters will have a unique ID no matter what. It should do that to an extent. You can't have a very, very long string. I don't think that would be able to say the same number as another set of characters, but that's interesting. So we'll go on to the next subject, which is uses of these hash codes and collections, or maps and collections. Doesn't really matter, just data types or structures or something. So there's one of these that's very important, and that's sets. Sets hold a set of values, and they don't hold the same value more than once. They hold a unique instance of a value, I think. So we'll try this out. We'll say set string, and then strings equals new hash set string. I don't know why I'm using hash. I believe that it's because it extends from set and I'm using it a specific way. I don't think I can use a set from the way I want to. I mean, I'm using a set, I'm using a hash set to initialize. I have no idea what I just said there. Alright, so let's try this out. Let's do system, let's see how it prints first. .out.println, and this is how you can understand what you're seeing in this object, strings. It's going to print out strings, and it does have a toString method, which means it takes the data it wants to show you, puts it into a string, and then spits it out at a line. Alright, so it's blank with an open and closing square bracket. Cool. Now let's add something into the string and see what happens. Strings dot add LOL. Alright. For one unit, we will have LOL and braces open and closing. Cool. And there's also space between L and the bracket. Oh wait, no, there's not. Okay, cool. So that L is just taking up space. Alright. So let's add another thing. We can also add more than one object in there. They just can't be the same. So let's have LOL2. Alright. So it separates each object with the comma. Interesting. Okay. So what else can we do? Well, let's try to add LOL twice. See what happens. Add LOL strings.add LOL. The reason I'm doing this is because it's different from a list, where lists will hold two objects at different indexes, and this one only holds one object of any type. If it has the same instance of that object, it will stack it and not make two places. So here LOL occurs once. And the way I'm going to explain this is this. You have a drawer, and your drawer contains silverware. You have a set of silverware. You have a set of forks, a set of knives, a set of spoons, and I think that's all you would have. Okay, so you have knives, forks, and spoons. I didn't say any of them more than once. I said knives, forks, and spoons. You don't say, I have knives, fork, and spoons. No, you have knives, forks, and spoons. They're all plural. You don't have to worry about them being multiple. A set of silverware contains a knife, a fork, and a spoon. You don't say knife, fork, spoon, spoon, spoon. That would be a list. We're dealing with just one instance of an object. And it only sets one instance. If there's more than one, it says, okay, well, we're going to add LOL in there. If it's already in there, cool, it's in there. It doesn't do anything else, it just omits it. It actually doesn't do anything. It puts it in there, and if it's already in there, it overrides what's already in there. And it appears to be 1, which it does, but it processes it. If you put it in twice, it says, okay, let's compute this real quick. Okay, it's already in there. That's it. It doesn't add another one. Now let's see what happens if we do entities. So let's try this. We'll put entity. Actually, hold on 1 second. Let's print out the hash code. Alright. So the hash code of our set is 75561. Alright, let's go system.out.println, and what do we put in there? We put in LOL, right? So let's get the hash code of LOL. Let's see what it is. Well, that's interesting. It's also 75561. And to clear that up, it does equal 75561 because I'm keeping it from printing out the strings. Cool. Alright, let's comment this real quick, and let's add LOL and then ROFL. Alright, well, we got a pretty big hash code there. How did that work? Well, we know that LOL is 75561. We know that. This hash code is not 75561. It doesn't look anything like it. In fact, I'm convinced right now that LOL Raffle laugh out loud roll before laughing is added to LOL. So let's see what happens. I believe that's how sets work. It just adds the hash codes together. So let's try this. lol.hashcode plus lol raffle dot dot hashcode. Let's not, or well, we can do that. Alright, so they are equal. That's what sets do. It just adds the hash codes together, because why not? There's no specific order, they're all numbers. No matter how you add them, they will be the same in any order. Sets are also not ordered. They're random, so whenever it spits out the same way, but if you insert or take something out, it doesn't look like it condensed itself shorter by taking the difference and then smashing the units together. No, it still scrambles them up in a random way. The same random way, but just depending on how things are removed, I believe. And it's probably random all the time. But let's see what happens when we just print out what's in this. Let's see. Alright, so raffle lol, and I guess it does it by whichever one has the bigger hash code. That might make more sense, but I'm not going to go into that. I actually don't know that, so there's nothing to learn here until I figure it out and teach it to you guys. So that's how this works. And let's try it with entities. So entity hash set entity. Alright, let's add new entity 0 0 10 1 first. The second. And this one's gonna be on 1 0 with a different ID. Okay. Now let's just take this line out because we don't need it. Okay. Now one thing you're gonna notice is it just shows us the class and then the memory tag in our computer to that object instance. It's not a hash code. In fact, it's random every time you run this. Wait. Let me take that back. I've seen random stuff before. Alright, well, it's appending data like we would a hash code, but it's doing it differently. So we're just going to put in a two-string method. So at override public string toString return x plus y. Actually, it's already right here. Cool. Alright, so it's telling us what was in there based on dividing it by colons, and we already know how those are arranged because I explained them. And I did it by hand. Okay. So there we go. We have our two things, first and second. They're not really supposed to be first or second. It's just however it decides to spit them out. I don't know if which one was entered first determines it, but could be. Nope, it doesn't matter. It still says first or second. Okay, so that's how that's arranged. And now let's see what the hash code looks like. Alright. And we already know that it adds the hash codes together. We already know that. We don't need to think twice because it does it with strings. It's going to do it with these hash codes the same way. And why is that important? Well, if we try to add a new entity that happens to be the same as the one that we have in there, and its hash code is not different, it's gonna think that they're the same thing and not add a separate one. So it thinks that unique hash codes are unique IDs, and if it has the same unique ID, we don't need to add it in there twice. That's how that works. And here, if we change this, we just change one thing in it. and we hit play, we get 3 objects. Even though these are the same, they aren't, because the hash code is different when we change that value there. And what I want you to note is that even though this is a new entity object, because we say initialize this object into the strings set, we should rename this entities, but I'm not going to. The hash code is still unique and it goes by that in the set. Cool. Alright, so what should we try? Let's see if we can do this. Entity B equals new entity, and then we'll make this one second. And then we'll also do one called A. Alright, so we're going to add A and B, and we have the same thing that we saw before, and that's okay. But here, we're going to do B dot X equals 10. Alright, that's an exception. I didn't mean for that to happen. Entity B equals new entity 10 or 10 to second. Let's see if this works. Alright, so it's no longer pointing to this one since we're making a new object here. This reference stays in the set, but we reset the entity B, and we're going to add it into the strings again. Alright, we get 3 separate objects. Cool. We get 3 separate objects here because their hash codes are different. Not that because we redid this, but because the hash codes are different. Now if they're the same, it's only going to have 2 objects. If all the values in this here are the same, it's going to think that these are 2 separate objects. I mean, are 2 the same objects. If the hash code returns different, they're different. So like, if I have the number 1, 2, and 3, those are all different objects from each other. But if 2 had the same hash code as 3, it would say, wait a second, this doesn't make sense. So, a good way to show that would be to have one variable in here that we can change that doesn't apply to the hash code, and to have it show where it went, and it'll just override the current one which is in there. So like, if I put entity B into the set, and I said that unique variable that isn't applied to the hash code is B, and then it spits out B from the set, I say, okay, well, it's added in there again, but this time that unique variable now says C in entity B. It'll override the current object in there, and it'll say C, because that's how sets work. If you reapply the same object, but the inner variables are changed, it'll override even if it's the same hash to code. It just won't add a new instance into the set, because like I said, we're categorizing things, and we don't need to add the same category in there based on the hash code. Hash codes are basically unique categories, and in the alphabet, each letter is a unique instance of a letter. You don't have B in the alphabet twice. You don't have 0 in the number line twice. Whole number, or well, no number 0. It doesn't appear twice ever. Now maybe the character 0 does, but not the number 0. Okay, let's observe what the set is. It says a collection that contains no duplicate elements. That's the key there. Duplicate meaning that it goes by the hash code. It can only have one null element, which means that if either entities are null, null will only appear once, because, like I said, the alphabet does not have any multiple characters in it. And then basically, here it says, one of the contracts of all constructors and on the contracts of the add, equals, and hashcode methods. That's what it's using, the equals and hashcodes, to see if the objects are different from current objects in the list or in the set, and if they are different, add it to it. If they aren't, override the most current version of that object. And that's how that works. So let's go on to the next part after my Eclipse stops freezing. So the next part is HashMaps. As said earlier, we're using HashCodes and the equals. HashMaps do something pretty similar. So let's go HashMap test equals new HashMap. And we have to import and also set things here. So I'm going to start with integer and string. And then here, integer and string. And import. Cool. Alright, so the way this works is a hash map works with the key to a value. Imagine it like a door. You have a key to a door, right? This key can unlock one door in this case, but many keys open many doors in most cases. But for this case, one key to one door, one key to one value, if that makes sense. So here we're going to say test.put, and then we're going to say 0, the number 0, and the value that we're storing at 0 is value at 0. That's clear, that's precise, that's how I want the example to be shown. Now here we're going to do put 1, and we're going to set that string on 1, value at 1. Not that 1 equals this value, but we're just storing this object. We're putting a key object, and in return, when we call later, we're going to ask what is the value at this key object. It will return what the string value was set. So if that makes sense, at 0 we put value at 0. I expect in return, when I ask for what is 0 again, it'll say value at 0. Now I can change this if I want later. Like after I set this, I can reset it whatever I want. And we can do that. We could say system.out.println test.get 0. It'll print out the string for 0. So here it says value at 0 because that's the key we set for that value. If we return that key and try to retrieve what the value is at that key, it will give us the value at that key. That's how it works. But once again, it also deals with hash codes. That's the whole point of this video. Alright, so if we were to say get the value at 1, it says value at 1 because, whoa, we set it right here. I love this, by the way. Alright, so it's returning this object. It's not returning a saved variable within the hash map. The hash map is storing this object in the hash map and it's retrieving it. So any instance of this object is what we're getting back. That's how the hash codes work. That's why it needs the equals method. And the main reason why is because if we change this right here, I don't think if I can do this, it'll do that. It shouldn't be able to. Alright, well it does. Alright, so here's the problem we're going to have. And it's going to be very obvious. Actually, before we do that, we'll copy all of it first. Alright, here's a problem that's going to occur if you don't or well, let's just show what it looks like. Let's just print out test. The way it puts toString, it's pretty unique. Alright, so it tells us 0 equals value at 0 and 1 equals value at 1. Now 0 doesn't equal the string. The key at 0 equals the value at 0. So whatever we set to 0. I think I've gotten that down. Okay, so we see how it's seeing the map right now. Cool enough. And that's how that works. Now let's say test.hashcode, and it's gonna do something that isn't really like that. I don't think that has to do with any content. I've never figured that one out, but that's what the hashcode looks like. Okay, and we already know that 0's hashcode is 0. It should be. Let's see. Integer dot. I hope it is. Alright, so it's 0. Let's see what integer 1 is. 1. Alright. Easy enough. Numbers can't get mixed up. One number is that number. If you tell it what that number is again, it's gonna have the same hash code. I think we're aware that instances are definite based on hash code. Okay. So here's what I'm going to try, and you're going to notice this right away. Value at 0 with a capital 0. Test.get 0. Alright, it updates what was set at 0 before, and this is no longer in the array list or in the map. That's what we're looking for. Cool. So now let's try int arrays. And one thing I'm going to say right now is the arrays are not handled the same way as objects. They do not have a hash code like objects have. There is some reason that's like that. So let's print nothing right now. Let's say test.put new int array 0 0. Oops. Alright. And then let's say test.get new int 0 0. Okay, so you think to yourself, since this is an array, it should know that this is the first entry, and we can get the hash code of that and then add it to that. That's not how it works. If we do this, it's going to say null because it can't retrieve anything. That's because whenever we have new instances of arrays, their hash codes change. And we can observe that by going like this. New int array dot toString, or well dot, I mean it has a hash code but it's not the same, plus new int array. And the way to fix this would to be make your own integer, like any array you're gonna use, wrap it around, like make a class to hold that array and modify the elements of it, and you're good. And you just adapt the hash code to how many elements are in the array, and then the hash codes of each array. It's basically an array list, sort of, except it only deals with this kind of an array. Do it however you wish. It doesn't really matter. You can figure that one out. Okay. And you'd think that these would be the same, but they're not. They're actually random all the time, not just once. like we just print out 00's hash code because we're initializing a new one each loop, it's updating it. But if we did it on the outside, so if we said public int array hold equals new int, or wait, nope, equals okay. So it remains the same because we're not creating a new integer array over and over and over. But if you did, and you did it inside this where it's being looped, it would change its hash code all the time. And you really don't want that to happen. The reason why is because when you set things in here in a dynamic loop like that, and you're initializing everything within your loops and you're not saving them out here, and if they have changes in their variables, you can't tie down a definite value or a definite key. If that key's hash code changes at all, you will lose the value if you do not know what that hash code is, or you can't apply that hash code again. So if you lose the hash code, you will lose basically the key or the value to that. And well, you can't lose the value because it sets the object to that hash code object. But what I'm trying to say is if you lose the key's hash code, you can't retrieve anything from it. And that's the issue there. So yeah. And that's about it for this video. I'll make more in-depth things about collections later on, and we'll use them. So hope you liked the video, subscribe for more, and I'll be happy to make some more videos soon. See you guys later.